Beginners webinar today. I'm Sean Ferrier, and we're going to be discussing mold design topics for beginners, kind of a broad overview with some discussion and some examples as it relates to some mold design functionality within the e.t.c Creo Parametric Suite. So we're also going to have a question and answer session at the end of this, and we'll discuss, all of these things as we go through. So as we go, let's get started right away. So our agenda for our webinar today is going to be to review and demonstrate Creo Mold Design for beginners. The theory of that agenda, if you will be a short introduction with a few slides that both introduce myself, Boundary Systems as a company, and the topics that we see here that we're going to discuss, and then we'll have a demonstration inside the software itself, and we'll look at these things kind of in a one-by-one workflow way inside the software and have some basic discussion about, accessing this functionality inside of Creo Mold Design. We'll talk about the different aspects of Creo Mold Design as you see here inside of our topic overview. At the end of this, we'll wrap up with a question and answer session. I would humbly encourage everybody to use the GoToMeeting question and answer type-in functionality. The webinar by default keeps everybody on mute, so the audio stays pretty clean. So the best way to to ask a question for me to answer is go ahead and punch that out to me at the question and answer session through the GoToMeeting interface. Now, that being said, if a question comes to mind during the course of the presentation, don't hesitate to go ahead and type those questions in early. I'll go ahead and loop back around to those as soon as we get to the question and answer session. They kind of pile up for me in a queue, if you will, so there isn't any problem for me to get to it later. You won't be forgotten or anything to that effect. So by all means, don't hesitate to ask questions at any time along the way, but we are going to have the formal session where I work to answer them towards the end of the presentation. During that time frame, if I'm not demonstrating or speaking to something specifically in Creo regarding a question, I'll be keeping my contact information as well as the company contact information. It's very important on the screen at that time so everybody can kind of screenshot that, type it in, get a hold of that information on how to follow up in the future for more information, help, etc. So that's kind of our 10,000-foot view of the agenda today. That being said, a little bit about me before we get started. A little bit about my background. I kind of come from the space of things of mold design a little bit, if you will. I've been working with e.t.c, design and engineering software since 2001. I've been a certified trainer with e.t.c since 2007. I'm typically called to perform things like training, consulting, and implementation for the company Boundary Systems. My focus areas personally include large assembly, schematics, cabling and piping, and all things manufacturing. That would be mold and all things CNC that fall into that kind of domain. Some more important things about Boundary Systems. They are a technology leader in this space. Their partners include e.t.c, obviously, as our primary focus topic today, e.t.c and other technology companies, one of the 16 fastest growing companies in Cleveland. It is part of the PDSVISION group of global companies. Capabilities include product lifecycle management, data management, obviously CAD design and consulting, kind of closer to the theory of our discussions today, simulation and product development. Boundary Systems has been bestowed upon many awards in recent history. Some of them are listed here. The solutions that Boundary Systems works with to better increase productivity and usability for their clients would all be listed here. e.t.c obviously at the top of the list being our focus today. Other partners, Moldex 3D being relevant in the aggregate to our discussion today, as Moldex 3D is our simulation plastic injection molding simulation product available to people in the plastic injection molding space. Arguably, we may have some relevance with those folks in the topic today, if you will. So make note of the partners that are here. Boundary Systems works with all these folks to better serve their clients and get the right solution in front of the right problem or the right need, if you will, in front of the client. So again, Mold X3D, definitely worth a look in possibly being very relevant, again, in the aggregate possibly to our overall theory of discussion today. Okay, Boundary Systems training capabilities. If you want to learn more about Creo Mold Design or virtually any other topic in the entire PTC space, or for that matter, any of those partners that were shown on the previous slide, Mold X3D, for instance, or others, all the presenters, there's a host of certified trainers available to you to access through Boundary Systems. Training is available both virtually, given the current COVID climate that is ongoing, as well as in-center and on-site, depending upon local circumstances or company policy, whatever the case may be. Obviously, these things are not all as they were, you know, a couple of years ago, if you will. Check our website for the full schedule of classes. Those things are always updating and changing because of participation improvements and such, if you will, as people collect, more and more classes get scheduled. Okay, so with that, let's get right to the discussions today that we're here for. So as I mentioned, we're going to talk about a handful of core topics as it relates to Creo Mold Design, and we'll kind of speak about them in a 10,000-foot view here on a slide, and then we'll open up the same kind of data set in Creo and kind of go look at these things and, how did we get to the point of having this information available on the slide. So, mold layout. Mold layout is a terribly important part of the Creo Mold Design ecosystem. A lot of times it gets a little bit of, foregone conclusion in terms of training and discussion, unfortunately, but arguably it's very significant. In most production environments, as a trainer in this concept and space, I would encourage most tool designs, as we're going to look at today, to start, if you will, and build down from a mold layout, as opposed to, building just everything inside of what would be the next slide that we'll speak to, which is, cavity, if you will, mold cavity. Advanced functionality for defining the mold base, assembling the cavity, which we'll talk about on the next slide, and creating water lines and runners, applying ejector pins, and working top down from a skeleton model. The example in case in point that's going to be used today does utilize the theory of top-down design management and a skeleton model, so that, arguably we have a very clean data reference sharing environment inside of the tool design, where as I need to share information both across multiple components of the mold base, as well as the cavity insert assemblies themselves, I have a very effective way of doing that and managing that inside of mold layout. In my own personal opinion, for what little of that I should probably divulge into today, I do believe that things in the space of runners, most definitely, and ejector pins do play best to be defined, controlled, and managed through the mold layout functionality, as opposed to doing that stuff in the duplicate functionality, if you will, that does exist inside of mold cavity. Obviously, when we speak to ejector pins, we're talking about an object that intersects not only the cavity assembly, insert assembly itself, as well as multiple components in the mold base. And the mold base does have some theory of its positional definition with respect to, the assembled depth of the ejector pin as well. So the mold layout really does become an ideal environment to work with setting up and managing some of these key component parts that go into a typical plastic injection mold design, and many other mold design theories, not all of it being explicitly plastic injection, obviously. But the moral of the story being is mold layout is optimized and set up for those things. You have dialog boxes for assembling standard mold bases, as you see exampled here on our screen, and other functionality here at this level to do things like water lines, runners, etc., as we discussed. And the big thing at the end of the day is really the ability to utilize the skeleton model for reference control and management of the overall mold design assembly, especially when you get into mechanics and externals on the mold base itself, moving hydraulic cores, things to this effect, unscrewing assemblies, etc. That adds a notable layer of complexity that in most all cases, in virtually 100%, we have an overlap of positional and mechanical definition that intersects both the mold base as well as the cavity insert assembly. So having those things at that level and managing that with the skeleton model becomes highly advantageous. Mold cavity. Advanced functionality for assembling the molded part, creating cavity and core inserts, designing the parting line, and optionally defining water lines and runners. I say optionally on this slide is because of a follow-up to my previous discussion in sharing that I do have a personal bias that those things are typically better declared inside of mold layout as opposed to being declared here, in spite of the fact that the functionality exists in both cases. Mold cavity is intended in a PTC workflow theory to be utilized to handle the part of the mold you see on the screen right now, the cavity insert splitting assembly itself. And there are enormous amounts of flexibility in how you would approach this. Many people approach multiple cavitation inside of a single insert and then multiply inserts throughout the tool also. Some folks will have a cavity insert set per cavitation, as you see in the example that I'm showing today. There is a cavity insert set, as you see here on the screen, that is duplicated and arrayed, if you will, inside of mold layout to produce a two-cavity tool. But in order to optimize the designer's time, there's no need to design the duplication of these things. We simply create the single insert set, as you see here, representing a single cavitation inside of mold cavity functionality, and we duplicate and cavitate, if you will, those insert sets inside of mold layout. And mold layout has extensive functionality for arraying and positioning, rotating as necessary these cavity insert sets that are created in the mold cavity functionality itself. And that is the base workflow that is, adjoining the cavity set to the mold layout. And hopefully that brings more context to the concept of mold layout. Inside of this environment, the functionality that's typically being deployed is, as I mentioned, creating cavity and core inserts, designing the parting line, and assembling the molded part into a 3D position inside of these things that will be created. Mold cavity has an enormous amount of functionality optimized that, we could speak to just that alone in the context of this webinar. Unfortunately, we can't, fit all of it into a single webinar, if you will, but there's an enormous amount of functionality here that is highly powerful for the aspect of doing all of the divisional operations that you see on the screen in this example that are necessary. We have to create space claims for heel blocks and sliders and inserts and stuff inside of pins, etc., inside of the mold to declare all these spaces and make all these component parts, or declare them on a bill of materials, if you will, so that they become included in the tool design. Creating those divisions and those space claims and defining a parting line, as we'll talk to here in a second, if you will, inside of this cavity, we have very optimized tools for doing those things. We also enjoy all of the stuff from, as we'll discuss later, all of the stuff from Creo Parametric. Okay. Shrinkage, one of the most important parts typically involved in molding or designing of a mold tool, if you will, is handling the shrinkage on the component part. PTC is incredibly strong in the way that shrinkage is being deployed inside of the mold design universe. It deploys as an editable shrink feature inside of mold design, as opposed to the typical workflow available inside of parametric, which is dimensional alteration when we scale an object. And it does have an unfortunate byproduct of essentially modifying all of our dimensions when we do this in parametric without the shrink feature. It hasn't, what most people, believe to be a net negative result in this context, in that it alters things dimensionally. And it kind of creates that effect on the model, and it doesn't produce an editable feature for that workflow. Whereas in the context of utilizing mold design, when we deploy shrinkage, we have an editable feature that supports both isotropic and non-isotropic workflows that allows us to go back and change the shrink feature in terms of a dimensional value explicitly, and have that shrink feature and its effect exist exclusively of the design part's dimensional inputs. So the design part has a dimension inside of it of 1 inch. The shrink feature, alters the design part and grows it as necessary to account for the shrink that's being, dealt with. But at the end of the day, the dimension, the root dimension in play here on the model remains the same. So if I were to go back and edit that dimension and do an edit definition, I would still see a 1 inch dimension. It works quite elegantly the way PTC has deployed this. And again, this is something that we apply to the design model after creation, because shrink is a factor of design and molding, design for molding. It is not necessarily a factor of design for intent. Parting line. The full suite of Creo parametric surfacing is available in Creo Mold. Sweeps, blends, fills, etc. Everything. Full stop. Variable section sweeps, wet blend, fill, boundary blend, you name it. Anything in terms of a core surfacing tool that exists in Creo Parametric is available to you in Creo Mold in order to facilitate creating parting line surfaces that can divide the mold in half and take care of those duties to kind of deal with seal-offs that we might have. We'll speak to those here in a second. Freeform ISDX surfaces, if you will, are also supported in Mold. Obviously, that requires an additional license to support the creation of those types of features inside of the Mold environment. If you don't have an ISDX license, you're not going to add those types of surfaces into Mold, but there are absolutely no problems in doing that if you do have the functionality to perform the higher order surfaces in ISDX. Advanced mold-specific surface functionality exists. Shut-off, volume split, etc. I've kind of previously mentioned some of these. We're seeing an example of an advanced shut-off surface being created on the slide now. We see that, those holes, those long finger-shaped holes, if you will, that roll over that edge of the part that has surfaces highlighted in green, those would obviously have to be capped off on the reference part in the intent of parting line creation. We see here that we have nice optimized functionality for creating those little surfaces to do that and spare us the busy work, if you will, of mechanically building out those surfaces using Creo conventional surfacing tools or something to that effect. This allows us to cap off very quickly and painlessly for stuff like this, and it is a shut-off surface that is collectible in parting line workflows and things to that effect. So it's really a nice thing to help optimize the creation of parting lines, and the inputs are very simple and arguably pretty user-friendly. Whoops, I go too many. Nope. All right, there we go. Runners. Runners, another key component in, I would say, arguably a great majority, not all, but a great majority of injection mold design, or mold design in general, if you will. Obviously, the theory of runner doesn't speak to the theory of hot drop, if you will, or hot runner direct cavity gating. In those kinds of workflows, the concepts of, what we would do there kind of a little bit exceed what we're doing in this workflow today, as this is more of a beginner's overview. But nonetheless, those things are obviously all manageable in there. But runners, I acknowledge, are an atypical case in those types of tool designs. Creo Mold Design offers robust runner designing tools. Basically, you get to work off of a sketcher that everybody's really all familiar with, and you get to do some cool stuff that you typically don't get to do in Creo Parametric, like have intersecting lines and overlapping sketches and things to that effect to help optimize the theory of waterline creation. You get to break a couple of rules in Sketch, if you will, when you make water lines inside of mold that you wouldn't typically otherwise get to break in a Creo extrude feature on, the parametric side, if you will. So the tools, while they utilize conventional, familiar Creo functional workflows like the Sketcher, that is additionally optimized to speak to the needs of mold, things like I mentioned, overlapping sketches, things to that effect. Runner tools are available both in mold cavity and mold layout. As I kind of previously mentioned, I'm biased to doing these things in mold layout. The example that's shown on the screen is some reasoning behind that. It's very typical in a lot of tool designs that the runner will intersect more than just the cavity insert set. Again, the hot runner example, that I just spoke to, being arguably some exception here, clearly. But in most cases, we're going to have a scenario where runners in a conventional sense intersect more than the cavity assembly. It makes a lot of sense to me to hang that stuff up in the skeleton model or whatever the case may be, or at minimum, be hanging those features in their definition inside of the mold layout as opposed to mold cavity, so that I could do things like what you see on the screen here, where the runner has been cut from the shutoff insert, the sprue shutoff insert, across into, from that across into the cavity insert itself. And arguably the runner shutoff insert obviously does not exist inside of the cavity split assembly. It exists at the mold layout level. So it's kind of handy to be able to hit more than one part with things like runner definition and stuff to that effect. It's, in my professional opinion, another big reason to be using mold layout effectively, as opposed to be using, just cavity split to try and get through everything, all right? It's not that it's impossible. A lot of this functionality does exist there and live there, but if your needs are for a fairly complete tool design, it definitely affords you, notable workflow improvements, in my opinion, to be working down from mold layout as opposed to up, from cavity split, if you will. Creo surfacing tools can supplement advanced runner designs. If you got the unfortunate workflow of having to create cashew gates and other interesting features like that, you will have to supplement, and you obviously can supplement some of those more advanced runner designs by utilizing, Creo conventional surfacing tools and cutting the insert parts themselves with those surface forms that represent, shapes like cashew gates and things to that effect. Again, this speaks to a lot of why we have the flexibility that we have. A lot of folks like to handle gating because of complexities like that inside of mold cavity, and then, connect those gates, if you will, inside of mold layout, where we can utilize the functionality of interacting with, objects in the mold base, if you will. So runners optimize functionality, very similar to what I mentioned what I mentioned before, in that we can have overlapping sketches, things to that effect, very much optimized for the workflow of doing runners. Water lines, another key topic that has to exist inside of many typical tools. We use, again, familiar Creo sketches. This is available both in mold layout and mold cavity, and we can handle waterline conditions easily. It's a part of this workflow. What do you want the end condition to be? It could be counterboard or something to that effect, because we typically plug a lot of the ends where they punch out of an insert or something to that effect. This workflow can be handled inside, again, of cavity split, or it can be handled inside of mold layout. There's probably equal number of people in both camps in that side of where they would arguably prefer to do water lines. You see here in the example that I've shown on the screen of editing definition of a water line layout. Again, same theory. The sketcher is the typical thing here, but it's optimized. It shows you the thickness of the water line as, if you will, representations beyond your primary sketch line. You are allowed to do things like have intersecting sketches and overlapping sketches and things to that effect, as you see existing here in this example. So it's incredibly convenient and well optimized for doing things like defining water lines. Ejector pins, another very typical topic. Not everything comes out on pins. I get that. A lot of times it's lifters. A lot of times we hold it in the tool or something because of drop conditions and damage, etc., and we'll hang apart on lifters or whatever the case may be. But in a lot of cases, we do deal with ejector pins of some flavor, arguably return pins, in my opinion, that most every tool has are a form of ejector pins in and of themselves, but they do come with the default mold-based examples, or excuse me, the mold-based definitions from the PTC mold-based library. So it's not like you have to make your own return pins, but if you do have to make custom mold bases and you are developing these things up, you would be able to utilize the Ejector Pen Catalog that I've shown on the screen right now. So we have a catalog of things like ejector pins that allows us to add legitimate PRTs as ejector pins in. We have advanced functionality with this stuff to trim it to adjacent functionality in the tool and get it clipped off to the right height and things to that effect, so that we trim these pins back to the reference part, and then we don't have to worry, they all come out to the right height, and we have a definition for all of the pins and all of the different heights. Ejector Pen Holes with advanced pass-through and counterbore functionality can be created in both mold layout and mold cavity. That's one of those that Sean really advocates for doing in mold layout. When we talk about ejector pins, as I mentioned very early in the webinar today, that's an object that's going to intersect a whole bunch of stuff. It's going to intersect ejector, mechanics in the backer plates, the cavity inserts themselves, etc. We have different pass-through diameters for virtually all of those objects when we speak to ejector pins, and the holes that are necessary for them. It's just really a workflow that plays well to be doing in mold layout as opposed to in mold cavity. Okay, with that, we're going to go ahead and start the webinar demo. I'm going to put the slides away for a bit, and we're going to kind of go ahead one by one, take a look at these things and accessing this functionality and looking at some of these things inside of Creo Mold. Okay, so with that, we'll go ahead and get ourselves set up here for Creo. Okay, bear with me. All right, so let's go ahead and get our object open. Now, one of the first things to note that is important is when we start talking about things like mold layout and cavity split, these are different types of assemblies in the Creo ecosystem. And it can, we get into big folders. There's a lot of stuff in here. It pays to take advantage of your subtype on opening up these objects and going and finding them and things to that effect. There is a mold layout object that Creo will go find specifically, just like there is a mold cavity object set that Creo will go find specifically in the theory of mold design. We're going to be starting with our mold layout here. That is our mold demo assembly. So we'll go ahead and open this up, and this is the tool that came from the slides. Now, the first thing we talked about on the slides was the essence of mold layout. Now, to speak to mold layout, this is the functionality that exists inside of mold layout. It has functionality intended for locating cavities, dealing with mold bases, assembling an injection molded machine on top of the tool if there's a need for doing so. There are a few of those in the library to choose from. You can do things like reference model cutouts and things to that effect here at the mold layout level. However, in the inverse of what I've been saying here a little bit lately, that's a workflow I believe should live at mold cavity level, not at mold layout level. We talk about subtracting the reference model and doing those types of operations. We're really speaking to the context of building parting line and doing the divisional operations on the cavity insert set. That stuff plays better in mold cavity as opposed to in mold layout. Okay. Again, we see the ejector pin hole, waterline runner functionality. We can define a mold opening, which is a similar workflow theory to doing an exploded view of an assembly. So we can see the mold open and see it open in specific steps along the way to get an idea of how moving components might respond inside the, or get a visual idea of how moving objects will respond inside of the real working world for our mold. We have control for layout, analysis, and thickness checks for the reference part itself here inside of Mold Layout. Mold Layout affords us the ability to locate a cavity and access the mold cavity functionality here on our menu over here. So if I wanted to access the mold cavity, that we'll do here in a second, I would simply select mold cavity here, and it would take me to the mold cavity assembly that is relevant to this file. When we speak to locating cavities, we can create a definition and define our layouts to be circular, variable, rectangular, etc. And this is where we would be handling the cavitation of our inserts from mold cavity. Again, as I mentioned, there was only one insert set designed, and we have a 2-cavity tool. So what we have done is we have patterned using the layout functionality, and you see the pattern definition at the top of my tree is the second object on my model tree. We have patterned that cavity insert set to create our cavitation in mold layout, as opposed to designing a whole bunch of cavities inside mold cavity. That really wasn't what PDSVISION had in mind. Again, I put an asterisk on that, and I recognize that there's a lot of instances where we do multiple cavitation inside of a single insert. And I think everybody understands kind of what I mean by both of those things and where PDSVISION's definition really lies here. If any of that's not clear, obviously we're here to help and speak to this again more in the future. And as I mentioned, my contact information will be up there for that. But as I said, this is functionality intended to define where these cavities live, what their layout is in the mold base, and handle that here so that we only have one set of cavities as opposed to multiple definitions of cavities being kind of duplicated, if you will. As we mentioned, mold layout is intended to handle these things. Runners can be managed here, water lines, ejector pin holes, etc. All of this functionality lives here at the mold layout level. We can define a mold base, and there already exists one, so it's not necessary, but I can simply activate the mold base catalog here, and here I can choose from different vendors, and I can choose from different standardized sizes. If I'm working with a standardized size mold base from a typical provider, DME, Hasco, and stuff to that effect, okay? And you can set up the ejector house definitions and things to that effect here as part of that customization for selecting that standard size base. So we have catalog functionality that can be accessed right here within inside of Mold Layout. We obviously also have, as I mentioned, Ejector Pin Catalog functionality. So we have a catalog both for ejector pins and workpieces. Again, I don't necessarily find that the workpiece catalog to be terribly relevant. However, the Ejector Pin Catalog does have a degree of definite relevance in it. And we can simply select ejector pins from our catalog after we tell PDSVISION where we're going to put them. We can simply select them from the catalog. We have a couple of, obviously we can work in English and metric units, and we have actually more than a couple. We've got about 5 different vendors that are participated in the catalog that, we can select standardized pins and things to that effect from and create an ejector pin component on the fly with the correct specification that, meets, and see it true to life size as necessary inside of our design. So we also have optimized cataloging for things like ejector pins here inside of Mold Layout. So with that being said, those are the things in Mold Layout. To take a look at the Mold Layout tree, you kind of see the definition of the structure that I've created here. We have our skeleton model, as I mentioned. The skeleton model has things like this pattern. I'll kind of zoom in there. A pattern definition, we'll just look at the ejector side here. We'll go to that combined view. We have things like a pattern definition here that I'm highlighting. You see the little green circles, and that's defining where my ejector pins are going to lead, or excuse me, where the ejector pins will live. I have some ejector sleeve definition and things to that effect going on in here, where my support pillars are going to be defined, etc. And these are just basically datum point arrays on a sketch that say where these objects will be patterned off to. And they defined inside of the skeleton, so the concept of them interacting with multiple parts is handled elegantly by default in the workflow. So the skeleton model is a part of what I utilize and encourage the utilization of inside of mold layout to optimize many of these things in the tools that affect many different components. We speak to support pillars. We're cutting holes for multiple components inside of the ejector house. We're bolting the thing on to the backer. You know, it's a lot of things that are interacting with each other, and managing these objects through a skeleton model does in fact make an enormous amount of sense to really keep things clean and optimize your tool design. But you can kind of see here, I've also got a couple of electrodes in this example. You can manufacture your electrodes for creating the tool, obviously right inside of the mold layout design. At the mold layout level, I can create electrodes for manufacturing of the tool and simply put them away in a simplified rep, and then they only display under those circumstances for that particular representation, and I don't see them constantly inside of the tool design. We see that I've done some of my patterning work for the ejector pin holes here, and I've also patterned these components here for the sleeved ejectors that are kind of shown here. Okay, the mold base assembly is this 1016A that you see up here at the top, and the pattern here is our mold cavity assembly that we're going to go look at now when we say mold cavity. So when we say mold cavity, we open up the cavity split assembly, and we see that here. And as I mentioned, the cavity split assembly is intended to handle that nuts and bolts part of the tool design, where we create the intersecting inserts that are next to and related with the actual molding of the part. Things like the heel blocks and the mechanics of this tool that does have a slide pole in it are typically all defined in this context when it's done like this, and we have simple slide poles and things to that effect, as the work of assembling that and making the accommodations of it will happen inside of the cavity split. We see that this cavity split does include waterline definition in my example, as well as pins and other objects being declared in volumes here that become legitimate parts that end up, becoming part of our tool design as a legitimate Creo PRT object in our design. As I mentioned, things like shrinkage are controlled here inside of the context of cavity splitting. We simply access the shrinkage here inside of mold cavity, and we define it accordingly. In this case, it wants me to tell it what reference part we're going to shrink. And we see here, as I previously shown in the example slides, we have an editable feature. It's coming up and saying, hey, this tool was done with 6,000 shrink. It is done isotropic. It can, of course, be non-isotropic, and you can apply different shrink ratios and different vectors based on a coordinate system. That can be enormously handy in some material conditions and great disparities in component molding when there are huge disparities of thickness and length and width and other unfortunate circumstances with respect to the core part design that don't necessarily lend themselves to manufacturing well. The shrink feature is easy to manage here, and again, it does put a legitimate feature inside of the tree that you can subsequently just perform edit definitions on and make alterations to shrink. If you get deep in the tool design and at the last or middle minute, somebody's got to come along and change the material specification because they can. I know that never happens to anybody else, maybe but me, but when and if that does, we can edit the shrink at that time and subsequently just rescale the tool with elegance and not have to pick a fight with everything to make those changes inside of the mold design. Also, parting line, as I mentioned, we have parting surface optimizations here for creating parting surfaces, as well as reference part cutouts and mold volumes, whether we're creating a split of a volume or defining a volume in and of itself that will be subsequently split later. And again, with respect to our parting surfaces, when we create parting surfaces, we can do advanced things like the shutoff surface that I mentioned, in filling loops and such. There are specific manufacturing optimized workflows for that parting surface creation inside of mold cavity, as well as awesome things like silhouette curve that allow you to drop a boundary and otherwise silhouette curve over a properly drafted model. And I do say properly drafted model, and most folks that are familiar with the context of all things molding and mold design understand what I mean there. We do have to have a properly drafted model to get optimization out of the silhouette curve functionality. If we have breakdowns in the application of draft, or we're cheating in some cases because we have a very thin border on the part, a lot of times I see draft foregone. If we're molding it into and holding it obviously on the core side of the tool, a lot of times boundaries that are very short, something 3 millimeters or less or 100 thousandths, sometimes those get left straight and they get pushed off anyway. That can cause problems with silhouette curve creation. So I share that with a caveat to beginners. If you struggled with the silhouette curve tool, it does really insist on a truly correct draft set on the model that does not really exhibit things like neutrality of draft on the borders and things to that effect. It does have nice functionality to optimize which side of the tool the curve is created on and things to that effect. So very powerful tools inside of mold cavity to optimize the workflows of doing mold cavity. In the context of beginners, mold cavity should be doing this stuff that you see here now. It's typically the bigger overarching mechanics of our mold base and things to that effect. We do those workflows inside of mold layout, as I mentioned. Okay. Runners and water lines, etc., as I mentioned, are available here both inside of mold cavity as they are inside of mold layout. We have water line definitions here. I could simply edit the definition of one of these water lines here and then go back and edit the definition of my circuit. And now we're looking, I changed the background for the slide because the shading is kind of tough in this case when I actually pull the legitimate example up because the sketch color is very unfortunately similar to the color of that's given to the tool on parting surfaces, if you will. So we kind of see here the sketch layout that was used to create these water lines. In this case, they were done here, again, at the cavity split level. We have that functionality, water lines, runners, etc. Okay. Those things are available here inside of cavity split. And those are the optimized workflows that we would otherwise use to get through the cavity split process that we would then otherwise manage inside of our mold layout. Okay. At the end of this process, in some cases, to come a little bit full circle to some of the slides that we spoke to earlier, one of the things that we can create is a molding in this concept. It's available to be created for, at this mold layout level to create what we call a molding. And in doing so, that allows us to create a representation of the sprue, all of the runner set, and all of the cavitation that exists in the mold, and consolidate that into a Creo PRT that can be subsequently sent off to, something like Moldex 3D for analysis and things to that effect. And it would represent the whole tool if we wanted to do a whole tool simulation in this case. A lot of times we optimize simulations and we only do one cavity because we want to optimize the simulation time of plastic injection molding. But in cases where it is relevant to fully simulate the tool, all of the runners, dissimilar family molds can be a very typical example of this. When we do family tools and we have multiple cavities, but the cavities aren't all the same, a lot of times that can be a huge asset to be able to make that molding representation from the Creo mold layout level to share with a simulation product upstream to determine that you're getting the expected results in a family molding as those can be some of the toughest stuff because of the dissimilarities between the components themselves, and therefore the response to the melt flow and the molding, operation physically as it happens. With that being said, we've got 15 minutes left here on the menu for question and answer, and I do want to kind of scale back over to that side of things. If we want to speak about any of those topics that we had on our agenda in greater depth, whether that be shrinkage, questions about that, or mold layout, or ejector pins, or whatever, as it relates to mold design, we've got about 15 minutes here to handle and field off any questions that I can speak to in that time. And please, by all means, I encourage that. I'm going to keep this Creo example up in the background while we coast through our question and answer, because I'll probably use it, hopefully, with some questions that'll come in that I'll get a chance to speak to. While I'm not doing that, I'm going to bring back our slides and bring back the slide that has my contact information on it. So, if you need more information about not only mold design, but virtually anything inside of the PDSVISION ecosystem, as well as those partners for boundary systems that were mentioned on the previous slide, things like Mold-X 3D, as I mentioned. Any need for anything more as it relates to any of that, my personal email and stuff is on the screen now. You can reach out to support@boundarysystems.com and get a ticket going with us to kind of look into things. We have a sales team that is ready to speak to any needs at any time that you have. Sales@boundarysystems.com, obviously. Obviously encouraged to visit our website to stay abreast of things like training schedules and things to that effect. Boundary Systems has an enormous amount of YouTube content now that is the very stuff of what we did today. Things to the effect of webinars that engineers like myself have been giving and providing for years now. It's typical there are multiple webinars on any given topic, or some topics have multiple webinars in different contexts, things like both basic surfacing and advanced surfacing, for instance, or something to that effect. There's been an enormous amount of content created by this team that is available on the YouTube channel that is the very stuff of our work and our review and things that we did here today. I can't speak enough to encouraging everybody to take advantage of that and go, if there's other parts of things that aren't even mold design, there's an enormous amount of content as it relates to wind chill, manufacturing, NC, whatever the content may be in the PDSVISION ecosystem, Mold-X 3D again. Those things are out there on the YouTube channel. Don't hesitate to go take advantage of that. And if there's follow-up questions that are created by taking advantage of looking at that YouTube content, don't hesitate to reach out to us. So with that said, please don't hesitate to start punching any questions that you might have into me. I'd very much love the opportunity to speak to a few questions before we wrap up today. So don't hesitate to utilize the GoToMeeting interface to ask questions, and we'll take the remaining time today to allow for those questions to come in and me to speak to those. So please, ask any questions that you might have, and I'll do my best to knock any and all questions that come in out between now and the end of our session here at 12:30. Okay, it doesn't appear that we have any last-minute questions coming through. Again, I'd encourage everybody to visit the website, reach out to me personally, reach out to our support team for any needs in the future. Boundary Systems and the engineering team will be here and the sales team will be here to assist you in any way we can. I thank everybody for your participation today, and with that, we will conclude our Creo Mold Design for Beginners webinar. Thank you again.